Hello students, in this lecture, we'll be studying about principle of superposition. What is principle of superposition? The statement says when a body is subjected to the number of forces acting on the outer edge as well as on the other sections of the body, the resulting deformation on the body is considered as the algebraic sum of the deformation of the individual sections. Okay. In such case, the total deformation is deformation that is delta L that is equal to the deformation produced by the each section. So it can be n number of sections. So delta L that is total deformation is equal to delta L1 that means deformation at section 1, section 2, section 3 up to n number of sections. So now put the formula of delta L that is nothing but PL by AE. So for section 1, it will be equal to P1 L1 by AE as the cross-sectional area of this kind of bar will be same. And Young's modulus will be also same because it is the same material. Next, similarly for section 2, you can put the value of 2, P2 L2 divided by AE. For section 3, you have to put the corresponding load and length value. Okay, the total deformation will be equal to 1 by AE multiplied by P1 L1 plus P2 L2 plus P3 L3 up to PL L. Now let's understand it with a simple numerical. A bar of cross-sectional area 1000 mm square is subjected to axial pull as shown in figure. Find the total elongation. Modulus of elasticity is given as 100 gigapascal. Okay, so this is our figure. Okay, so first what we have to do, we have to separate each segment A, B, and from this to this is B to C, and this is C to D. Okay, so at A phase, 50 kilonewton force is acting, so we will give it 50 kilonewton. Then at B, we have to also give 50 kilonewton to make an equilibrium position. But at B, we need 80 kilonewton in the direction of this, towards right hand side. Okay, but towards right hand side, we have only 50 kilonewton. So additional 30 kilonewton is required in this direction. So at B phase, we need 30 kilonewton in towards right hand side direction. So at B, let's give 30 kilonewton in this direction. And in C, it will be a equal and opposite force. That means 30 kilonewton in opposite direction. But at C, we require 20 kilonewton in this direction. That means towards left. But towards left direction at C, we have 30 kilonewton. Okay, so we have to reduce 10 kilonewton from this. So here at C, okay, we have to give 10 kilonewton because this in this direction it is 30, in this direction it is 30, and in this direction it is 10. Okay, so 30 minus 10, that is 20. So 20 kilonewton will be towards left side direction. Okay, and which is given in the question towards left side, we require 20 kilonewton. At the D, it is also required 10 kilonewton. So here this side 10 kilonewton, so also we have to put at this side that is 10 kilonewton. Because we require equal and opposite forces for equilibrium. Okay, so in this way we got 3 sections of different forces acting on it. Okay, now simple. Put the values in formula. A value given cross-sectional area is given 1000 mm square. Young's modulus is given, that is 100 gigapascal. That is nothing but 100 kilonewton per mm square. Okay, and the elongation formula is 1 by A P1 L1 plus P2 L2 plus P3 L3 up to PL N. But we have 3 sections. So this is P1, this is L1, this is P2, L2, P3, L3. Okay. Now put the values in the formula. 1 by area is 1000, E is 100 kilonewton per mm square. That means force we have to take it as kilonewton and length should be in mm. In first section, we have load of 50 kilonewton and the length of 0.6 meter. We have to convert it to mm. That means 600 mm. So 50 to 600. Similarly, for section 2, we have 30 kilonewton and 1 meter, that is 1000 mm. Next, this is 10, this is 1200. Okay, so here I have taken it as negative because you can see these forces are tensile in nature. At section 2 and section 3, the forces are compressive. Okay, the force which is compressive in nature, we have to take it as negative. So that is why these to see, that is section 2 and section 3, I have taken it as negative. Now after calculation, we'll get minus 0.12 mm. So there will be reduction of 0.12 mm when this type of force is acting on. The next question is, a steel bar of 25 mm diameter is loaded as shown in figure. Determine stresses at each part and total elongation. Modulus of elasticity is given as 200 gigapascal. Okay, so as I have already told that we have to separate each segment and balance the forces. Okay, here you can see A, B, C, D, you have to name the each spaces. A to B, one section, B to C, second section, C to D, third section. So at first section, at A, we have 40 kilonewton. So at A, we have 40 kilonewton. At B, we have to also give 40 kilonewton for the equilibrium. Okay, so this is, you can see this is tensile in nature. Next, but at B, we require 20 kilonewton towards the right side direction. Okay, and towards this direction, we have 40, but we require 20. So we have to deduct 20 kilonewton. That means 20 kilonewton will be in opposite direction. So at B, 20 kilonewton force will act in opposite direction. So in this direction it is 20. That means at C, there will be an equal and opposite force. That means in this direction it will be 20 kilonewton. Now you can see at B, the collective force is acting 20 kilonewton in this direction. That means 40 minus 20. That is equal to 20. So 20 will be in this direction. Okay. Now at point C, we require 10 kilonewton in towards left side direction. Okay. But at this direction, we have 20. But we require 10 kilonewton in this direction. That means at C, we require 30 kilonewton. Now see, 30 minus 20. That means equal to 10. Okay. So 10 kilonewton will be in this direction. At C, we are providing this 30 kilonewton. Then there at D, there will be an equal and opposite forces. So that means at this direction, we have 30 kilonewton. And it is also verified by this diagram because at D, we require 30 kilonewton. Okay. So you have to check that at each phases, the given values we are achieving or not. At A, we require 40, it is 40. At B, we require 20. 40 minus 20, that is 20 in this direction. At C, we require 10. That means 30 minus 20, that is equal to 10 in this direction. Then at D, we require 30. That means it is 30 in this direction. After seeing this, we can say that all are tensile in nature. It is a bar of 25 mm. That means area will be pi by 4 d square. That is equal to 490.625 mm square. Then Young's modulus is given 200 gigapascal. That is nothing but 200 kilometers per meter square. Then delta L, then the change in length will be equal to 1 by AE multiplied by P1 L1, P2 L2, P3 L2. Here the length is given in centimeters, so we have to convert it to mm. Here all the forces are tensile in nature. So here we are giving it as positive. For P1, L1, P1 is 40, L1 is 5. Then P2 is 20, L2 is 400. P3 is 30, L3 is 200. Okay, so after calculating, we are getting change in length is equal to 0.346 m. Okay. So there is another thing also we have to find out, that is stresses of each part. Okay. So stress is nothing but load by area. Area we know that is 490.625 mm square. So at AB, the load is 40 kilo. So 40 by area, you get the answer. Then at BC, the load is 20 kilonewton. 20 by area, that is, you are getting 0.04 kilonewton per mm square. Then at CD, it is equal to load by area, that is 30. 30 by 490.625. You are getting 0.061 kilonewton per mm square. There is another way also to do this diagram. Okay. Here we require at A 40 kilonewton. So at A it is 40 kilonewton. At D, there will be equal and opposite force, so that means 40 kilonewton. But here you can see that we require 30 kilonewton at D. Okay, so we'll achieve it later. Then take a section BC. So this section B to C. So at B we require 20 in right hand side direction. So put the total value, that is 20 kilonewton in this direction. So B part is over. At C, there will be equal and opposite forces. So that means if at B it is 20 kilonewton, at C it will be also 20 kilonewton in this direction. It is creating a compressive force. But at C we require 10 kilonewton. But here we have 20 kilonewton. We have to deduct 10 kilonewton. That means in opposite direction, just put 10 kilonewton here at C. So if this is the C is 10 kilonewton, at the T there will be also equal and opposite forces, that means 10 kilonewton in this direction. Okay. So now you can see at A we require 40 kilonewton, it is 40. At B we require 20 kilonewton, it is 20. At C we require 10 kilonewton. See, you can see here 20, this is 10, 20 minus 10, that is 10 in this direction. Okay. Next at T, this direction it is 30 kilonewton. Here you can see at T, towards right we have 40, towards left we have 10. That means 40 minus 10, that is equal to 30 in towards right hand side direction. Okay. So in this way also you can solve. Here you can see in the diagram we are facing two compressive forces. That means it will cause the reduction. So during calculation, we have to put the negative sign in this place. That means the formula will be 1 by A, P1, L1, but P1, L1 for this section, then minus P2, L2, minus P3. Now solving and inform me if you are getting the same answer.